solar energy storage, other uses of solar, solar cooking, solar water years throughout history, solar firsts, and fun facts about solar. I'm going to start with solar history. Solar history began as far back as 6,000 years ago, beginning with the Chinese. The Chinese understood a basic principle of solar architecture, that a house needs to be facing south to be warm in the winter and cool in the summer. They discovered this by putting a stick into the ground, sort of like a sundial, and keeping it that way all year. Eventually, they figured out that in the summer, the sun's path is directly overhead, and in the winter, the sun's path is shining more from the south, more oblique. So if the entrance of your house was facing south, then in summer your entrance would have no sun, and in winter the entrance would capture all the sun. Another trick was submerging most of the house underground to keep it cool and making long overhanging eaves to shade it even more. The Greeks have a part in solar history and took place in the 5th century BC. The Greeks were running extremely low on fuel for cooking, and eventually they figured out that they had another source of energy available to them, the sun. So if they could just figure out a way to harness that energy, they'd be okay. The Greeks are also credited with being the first ones to make a solar city, when many people moved to Olympus, Greece, to escape persecution from the Athenians. When all these people moved to Olympus, the city planners of Olympus made a new district called the North Hill district. The special thing about this district was that all the main streets went east-west, with more minor streets in between. This enabled them to make it so each house could face south and therefore be warm in the winter and cool in the summer. The Romans have a part in solar history when an engineer named Vitruvius visited Greece and saw the solar architecture they had. He brought it back to ancient Rome and demanded that it be used. How photovoltaic cells work. Photovoltaic cells are the main method of creating electricity with the sun's energy. Photovoltaic cells are also known as solar cells, and they can be wired in series to create solar panels. Solar panels are usually created with either silicon, boron, or gallium, chemically treated to make a positive layer or a p-type, and a negative layer or an n-type. There are a lot more silicon solar panels than there are boron or gallium solar panels, simply because it's way easier to get. Simply because there's way more silicon in the earth than there is boron and gallium. Besides acting like, before really understanding the concept of this photovoltaic cell, we need to understand the concept of light and electricity. Besides acting like waves, light also acts like a stream of tiny bits or particles of energy. These bits are called photons. Photons are so small that they can fit in the glass of a solar panel and knock out electrons that are set in rows. When one of the photons knocks it out, the electron next to it fills its place. This eventually creates an electric current, which flows out of the positive layer, goes to the negative layer, and then flows out to an inverter, where the direct current electricity that is produced by the solar panel changes to alternating current electricity. Alternating current electricity just switches directions a lot. There's another way to make. Solar cells can also be used as a sort of battery. The only difference between a solar cell and a regular battery is that solar cells only produce electricity when light shines on them. This is called a battery backup system. One example of it is one example of this sort of thing is a solar-powered calculator, which has solar panels directly connected to its body. A unique thing about solar-powered calculators is that they don't need the sun to shine. They can shine on indoor light. Okay. Solar energy storage. Solar storage is a big issue since the sun isn't always shining. You could hook up a battery to the solar panels, but those batteries are most of the time more expensive than just buying energy off the grid. Sometimes in remote areas, solar energy is cheaper, but even in remote areas, the solar panels are only able to send to the battery 40% of what they produce, and the battery is only able to use up to 80%. So in most cases, it's cheaper just to buy energy off the electricity grid. Okay, other uses of solar. There are 3 other main uses of solar: solar thermal collectors, solar concentration systems, and passive solar design. Solar thermal collectors are just heaters. A row of heat collecting panels collect heat from the sun and heat liquid to create steam to heat buildings. Solar concentration systems are rows of mirrors surrounding a tower, like here. All sunlight hits the mirrors, then reflects to the top of the tower, where it heats water to create steam, which turns turbines to create electricity. And there's passive solar design. Passive solar design refers to the use of the sun's energy for heating and cooling purposes. One example of this is the Rocky Mountain Institute in Colorado. Some common signs of passive solar design are operable windows and thermal mass. Thermal mass is sort of like insulation, and operable windows are windows that can be opened and closed. Okay, solar cooking. Solar cooking is cooking with the sun. The first ever meal 100% cooked by the sun was cooked by Horace Saussure in 1767. I don't know what the meal is. There was also a lot of other solar meals, but I'm not going to go in depth about those until one in the 1800s, done by Augustin Mozart. He came up with a solar panel, which he named a concentrator solar cooker. The special thing about the concentrator solar cooker was that it was portable, so it could be used on like military missions. The concentrator solar cooker was also extremely efficient. It could make a pound of bread in 45 minutes, and he boiled over 2 pounds of potatoes in an hour. Okay, solar water heaters throughout history. The solar water heater I'm going to talk about is a batch heater. Solar water from your conventional water heater goes through pipes to the batch heater, which would be hooked up outside, carefully aimed at the sun. When the cold water comes in, the cold water starts heating and therefore rises. Hot water rises, and then when it eventually gets to the top, it's pushed out by cold water. It's pushed out by more cold water coming in from the regular water heater, and then it's sent back to the water heater where it can finish the job. Okay. I have some solar firsts here. In 1975, the founder of Solar World, Bill Yerkes, invented a method of making solar cells reliable. In 1985, a community in Phoenix, Arizona, is the first community ever to make more electricity than it needs, and it wasn't until 2008 that solar panels could make at least what they said they would. Okay, some solar fun facts. Every square meter of the planet receives 1,366 watts of electricity every minute. Every 40 minutes, enough sunshine hits the Earth's surface to power the entire world's population for a year. There's also a way to make solar air conditioning, which seems to me a little bit contradictory. And that's about it. Thank you for listening.
Do people still use solar cooking today?
Yeah. You can make solar ovens for you can make a solar oven for a pizza box.
And so, do a lot of people use that, or do you know how many?
1/3. The UN estimates that 1/3 of the world's population depends on these.
On solar ovens?
On solar ovens.
Any other questions?
Yeah, I have another question. When you said that place in Arizona made more solar energy than they could use, is there like a market for being able? Can you let
if you
someone
make
else
more
use
electricity than you use, then you can put it back on the electricity grid for other people to use. Valentino?
For the squares of the panels of the different sizes, and when it's different sizes, is there more power in the bigger ones?
Because you can fit more solar cells, which means more electricity.
When you mentioned about the cost of solar, do you know, are there any places in the world today where it's cheaper to produce energy from solar as opposed to using natural gas or coal or anything like that?
Remote areas and obviously places that are generally more sunny. So here's actually a pretty good place.